Well, hello, class. Just me again. Uh, Wanted to take you through a quick refresher. If you guys didn't talk about this yesterday, I apologize, but let's finish it off right now. A polygon, if it is a polygon with three sides, is named, well, you know this one, it's a triangle. If it has four sides, four, quadrilateral. Five, pentagon. Six, hexagon. Seven, you might hear called a couple different things. The one we're going to use in this class is heptagon. 8, you know, is an octagon. Here's another new one, is a 9-sided polygon is a nonagon. 10, decagon. 12, dodecagon, very similar to your dodecahedron that you did your project on. And anything more than that would be a nonagon, or sorry, an n-gon, where n could be any number, like 11-gon or 17-gon. Here you see a picture of several polygons broken up into triangles. Now these triangles help us describe why there are so many degrees in a quadrilateral, why there's so many degrees inside of a pentagon, a hexagon, a heptagon, an octagon, so on and so forth. If I start at one diagonal, a quadrilateral can be two different triangles, each with 180. Therefore, there's 360 in a quadrilateral. Well, if I start at one diagonal in a pentagon and draw my diagonals in here, I have three different triangles, each at 180, for a total of 540 degrees. Hexagon, again, starting only at one diagonal, I draw the one vertex, drawing all the diagonals in. Four triangles, each 180, makes a total of 720. And you can start to see a pattern here. Well, if I have four sides, I only have two triangles. If I have five sides, I have three triangles. If I have six sides, I have four triangles. So how many triangles would a seven-sided or eight-sided or even a 90-sided polygon have? Well, here we go. So, number of sides of a triangle. 3. One triangle, 180. Quadrilateral. Four sides, two sides. So it's always two less. So if I had an n-gon, I would have n minus 2 triangles. So if I want to know how many degrees were in a 90-sided figure, I would do 90 minus 2, and then I would take that and multiply by 180 degrees for each triangle, and that would give the total interior degrees of whatever polygon that you're doing. It must be a convex polygon. This does not work with concave polygons. So here's three problems. Using this formula, I'm going to give you a little bit of time here to try part A. This is where you would need a calculator. The calculator would make it a lot quicker too. I mean, some of you might need a calculator, but why waste time doing things by hand? Well, convex octagon would mean that n, how many sides do we have? Octagon would mean 8 sides. So if I wanted the sum of the interior angle measures, I use this little formula. So sum of the interior angle measures is, and I would plug in n is 8 minus 2 times 180. I get an octagon would have 6 times 180, or a total of 1080 degrees, 1080 degrees inside of an octagon. Well, the question comes to bear, well, what if the what if it doesn't ask for all of the interior angles added up, the sum in other words? What if it asks for each interior angle? Well, the only way that we could do this right now is if it was a regular shape. So regular meaning all the angles are the same. So no matter if we have this n minus 2 formula, and I wanted each angle, all I have to do is take it and divide it by how many angles there were, or how many sides there were, if they're all the same. So in this problem, part B, a nonagon would mean that n equals 9. I plug in 9 minus 2 would give me the number of triangles in a nonagon times 180. And then I'm going to take that answer and divide it by 9 and get how many each degree would be of a regular nonagon. Now I know that this is 7 times 180 divided by 9. And if I can simplify this, I could probably simplify this without a calculator. But let's see here, 7, and then 9 goes into 18 2 times, so I have to have 7 times 20. I just divided 9 into one of these numbers since these are multiplied up here together anyways. So each angle in a regular nonagon would be 140 degrees. There's yet another type of problem that we have. What if we don't know that it's a regular shape, and we actually know that it's irregular, and these are different measurements in here, and we want to find out what each of these measurements are? Well, we know this is a quadrilateral, so we know n is equal to 4. Or you could even say that all of these angles added up. Well, we already know a quadrilateral has 4 angles, 4 sides that have to add up, and when you add them up, have to equal 360 degrees because there's 2 triangles. So C plus 3C plus C plus 3C, well, let's see, 4 plus 1 is 5, plus another 3 is 8. So we have 8C equals 360. Divide by 8, we have C is 45. So angle P is 45 degrees. And angle R down here is 45 degrees. And if I take 45 times 3, I get my other 2 angles, since those were both 3C's. So 3 times 45 is 135 degrees each. And my problem is done. If I add up 135, 135, 45, and 45, I do get 360 degrees, which is consistent with being a quadrilateral.